Welcome everybody. In this session you're going to learn about algorithm and flowchart. Algorithm is your first chapter and flowchart is your second chapter. But I feel only if you learn these two topics together, it will be easy for you to understand all the concepts. So let's just start with the first concept, that is algorithm. In our routine life, sometimes we need to follow a step-by-step procedure to carry out few tasks. Now, the step-by-step procedure which you follow to carry out these tasks, these particular tasks, particular task could be anything. Say, for example, if you are cooking something, say you are preparing a Maggi, then there is a procedure which you follow how to prepare a Maggi. Then say if you are preparing some other dish, again that procedure is also different. Now, task could be anything else, like you want to reach to a particular destination, the way, the method, the shortcuts which you follow, that is also a procedure which you follow. You need you follow some procedure to solve particular task. Now the step by step procedures which you follow to solve particular task is called as algorithm. Algorithms are generally written for solving mathematical and logical problems when it comes to computer programming. So in programming it will be mostly based on mathematical and logical problems. What is the goal of algorithm? To develop framework for instructing computer to perform task and to specify how to solve a problem. So algorithm instructs the computer what it has to do and how it has to do. So that is the procedure, that is a step-by-step procedure which algorithm gives to the computer. Let us do a small activity. The following are the steps which you follow daily in order to get ready for school. You need to rearrange them in correct sequence. Now I have given it in jumbled format. You have to just look at it for some time and then you will understand it is very easy. I've just jumbled it. You have to form a proper sentence. Now, having breakfast, check your school bag, take bath and dress up, wake up early in the morning, brush your teeth, go to school. So it is in jumbled format. So the first thing would be wake up early in the morning, then brush your teeth, then come take bath and dress up, have breakfast, check your school bag and then go to school. So this is the right procedure. As I said, wake up early in the morning, brush your teeth, take bath and dress up, have breakfast, check your school bag and then go to school. So let us take another example. Calling a friend on the phone. Pick up the phone and listen for a dial tone. So first thing which you do is you will pick up your phone and then you will listen for the dial tone. And then press each digit of the phone number on the phone. So you have to enter the numbers of that particular person's phone number. Now first condition would be if it is busy, you hang up phone. That is, if it is busy, you will hang up your phone and then you wait for 5 minutes. Again you have to start from the step 2, jump to step 2. That means again you have to start from press enter the digit of the phone number on the phone and then you follow. Again, if there is nobody is answering, then you leave a message and then you hang up. Again, if again you're doing, again you press the number and again you make a call and you see if there is no answering machine, then you hang up and then you wait for 2 hours and then again you start with step 2. Again you're going to enter the phone number on the phone and then you finally find your friend is talking and then finally after talking to your friend you hang up your phone. So this is a simple procedure. So in this you can understand that there are 3 possibilities. Say the first first time when you're dialing, it could be the number might be busy, then you have to hang up. Again you wait for 5 minutes, again you start, again you call, and then second time when you're calling, again if there is nobody is answering, then you leave a message. If there is an answering machine, then you will leave a message. And again if you find there is no answering machine, then you have to wait for 2 hours and then again you will make a call. Again by entering the number you will make a call and finally if your friend is talking, after completing your this thing, I mean that task is over, you have you spoke with your friend and then you hang up your phone. So this is a step by step procedure to call a friend on the telephone. Use of algorithms in programming. Whenever a program is written using any computer language, few languages are C, C++, Java, these are few programming languages, and set of operations is followed to carry out mathematical and logical problems. So when it comes to programming, set of operations are followed, certain methods are followed to carry out the mathematical and logical problems. In programming, algorithms are written to describe the sequence of various operations to be carried out in a program in a simplified way. So in programming, algorithm are written to describe, that is, as I said earlier, sequence of various operations. That is how to solve a particular problem. You are just specifying it in a very simplified way. An algorithm does not contain syntax of any particular language. Say algorithm, now these programming languages which I said, C, C++, Java, all these have certain rules and certain methods, certain rules how it has to be coded. Now algorithm doesn't need to be doesn't need to follow all these rules. It doesn't come under any rule. Simple normal sentence are used to write an algorithm. Let us take an example. Now this is based on the programming concept. So adding of two numbers. First step is read first number. That is first step. To add two numbers, what is the first step which we need is you have to get the first value. That is read in the first number. That is you are getting the input of the first number. Then read the second number. First number is say 50. Second number is say 40. You're going to add both the numbers 50 plus 40 and then finally you're going to print the result. So this is the step-by-step procedure which you need to follow to add two numbers. Okay. Now next is average of three numbers. Read the first number. Now when it is average of three numbers, you have to get three numbers as the input and then you have to calculate and find the average and then you have to display the result. Same thing. Read first number say 40, read second number say 20, read third number say 60. Add all these numbers, that is you're adding, that is one step. 120 is the total you have got. Again next step you're dividing that sum by 3. Now this 120 value, the 120 value has been stored in sum and you're going to divide the sum by 3. So 120 by 3 you have got 40. So print the result, that is 40. I hope you understood this example. So this is how you write step-by-step procedure of any task. Now another example is finding the biggest number. So you have been given with two numbers num1 and num2. See when it comes to computer, we the previous two examples I have given values directly 40, 20, 60. These are the values which I have given. So that won't be a general algorithm, that is specific algorithm only for adding those 40, 20 and 60. Now here this is an example where I have not specified any value. Instead of value I have given some variable names, that is num1, num2, etc. So instead of giving numbers, that is 10, 20 and all, I have given variables so that this is applicable for any example. You can put any value in this and you can find out the result. So first step 1 is you have to get the first value, that is read num1. Second step is read num2. So the first two values you have got. Check if num1 is greater than num2. So you are going to check first step is, as we have to find out the biggest number, so we are comparing num1 and num2. If num1 is greater than num2, then if true, move to the step 4, else go to step 5. Check if num1 is greater than num2. If it is true, that is if num1 is greater than num2, then you have to move to step 4, that is you have to print num1 is greater than num2. So you have got the result, that is num1 is the greatest one, num2 is the smallest one. So you have to print the result as num1 is greater than num2. And if it is not greater than num2, that is if num1 is not greater than num2, then obviously you have to go to the next step, that is again you have to compare num2 is greater than, whether if num2 is greater than num1 or not. So we will check, that is your step 5 is to check if num2 is greater than num1. If num1 is not greater than num2, then definitely num2 is going to be greater than num1. So if it is true, then you will, if true, then move to step 6. That is, if it is true, num2 is greater than num1, then num2 is greater than num1. And if in case num2 is also not greater than num1, then definitely it has to be an equal number. So print num2 is greater than num1 if num2 is greater. Otherwise, go to step 7, that is print num1 is equal to num2. So there are three possibilities, that is either num1 will be greater than num2 or else num2 will be greater than num1. If in both the cases doesn't satisfy, then definitely the numbers are going to be equal numbers. No other possibilities are possible. Let us continue with our next topic, that is flowchart. Flowchart is a diagram used to represent the steps followed in an algorithm. So as I said earlier, algorithm and flowchart are interrelated topics. So algorithms are step-by-step process of solving a particular problem, and the steps which we have written, those steps are going to be converted into a diagrammatic format which is called as flowchart. And flowchart, we can compare it with mind mapping concept, where you take up a concept and that concept is represented in a diagrammatic format, and it becomes easy for you to understand the concept also. The same case with flowchart also, algorithm is converted into a diagrammatic format and it becomes easy for the programmer to understand the concept. Now, what is the difference? The difference between this flowchart and mind mapping concept is there is no rule which we follow in mind mapping concept, but whereas flowchart we have certain rules, we have to follow those rules. Say if you are in a programming concept, when it comes to input and output, those input and output are represented in a different shape in flowchart, and the processing area, that is represented in a different shape. So we have certain rules which have to be followed in flowchart. Flowchart are drawn by connecting different boxes with flow lines. Each step of algorithm is written in a box, and different types of boxes are used to depict different operations. Now these are the symbols which we use in flowchart. The first one is flow line, used to connect symbols and indicate the flow of logic. This is a terminal, called as a terminal. So this is used to represent the beginning and end of a task. So whenever a programming or whenever the flowchart, you start with the flowchart, this is the shape which is drawn first. This is a shape which we use to end the flowchart also. And the next one is parallelogram shape. This is used for input and output operation. And next is your rectangle shape. This is a shape which we use to represent all the processing areas. That is, say if you take up two numbers, adding of those two numbers are the processing area, and when you're getting the input, we use this shape. The parallelogram is used for getting the input, and this shape is used to represent the process after getting the input. And this is a decision making shape. There are situations or problems where we need to take up decisions. For that purpose we use this decision shape, that is diamond shape. Let us just take an example of preparing a mango shake. So when you are preparing a mango shake or anything, we have inputs, procedures and output. That is, input is the thing which we give as input, and then procedure, that is the processing time where we do all the process, and then finally we get the output. So here it is an example of preparing a mango shake. So input is, to prepare a mango shake, what and all we need: mangoes, milk, ice cubes, sugar, glass and a blender. And the process is, first you peel the mango and cut it into slices, and then you blend the pieces of mango, add milk, sugar in the blender, gradually add ice cubes in it, and finally you stop the blender once all the things got mixed well, and finally you serve the chilled mango shake in a glass. So this is the algorithm. We can consider this as the algorithm for preparing a mango shake. Now this we are going to represent it in a flow chart. So as I said earlier, we start with the oval shape, that is start, and then next is the time when we get the input from the user. Now here it is only a mango shake preparation, so there is no problem with it. When it comes to programming, the sentences change. So this represents the input. So the input which we are giving to for this process is glass, blender, ice cubes, milk, sugar and mango. So these are the inputs which we give. So these arrows represents the flow. So once you started, this represents the flow. After this next steps come. So this arrow represents the flow of this logic. So next is, you peel the mango and cut it into slices. Then the next step is, blend the pieces of mango, milk and sugar using the blender, and then gradually add ice in the blender. Then next step is, stop the blender when everything gets mixed well. Now once this is over, the next step is, finally everything got mixed, and then now output, again we are using the parallelogram shape, serve it chilled in a glass, and then once that is over, your process stops. So again we are using that oval symbol to stop. So you understood, right? start, again we use an oval shape, again input and output we use the parallelogram shape, and then here we are using the rectangle shape to represent the process. Now again there is one more shape, additional shape, which I have used here is a connector. This is called as a connector, the A symbol which you have. Now here on the left side I didn't find space to continue drawing it, so that is why I have used a connector to connect. These connectors are used when we don't have space to draw it or represent that flow chart in a continuous way. So we just use the connector so that it represents. Now here A is given, that means continuation of this is represented here. So again wherever you are continuing, even if it is not in this slide also, if it is in the next slide also, again you have to use this connector so that it is clear that it is a continuation of this particular flow chart. Clear? Next, now flow chart for mathematical and logical operations. In programming, you can make flowchart for solving various mathematical and logical problems. There are three types of problems which can be depicted using flowchart. So when it comes to mathematical and logical problems, there are three types of flowcharts which we use to depict those particular problems. First one is sequential workflow, second one is selective workflow, third one is looping or iterative workflow. Now sequential workflow, in these types of problems, various activities are executed one after the other. It is not possible to go backwards as execution always moves forward. Example, multiplying two numbers. The example which we saw earlier for preparing mango shake is again an example of sequential workflow. So there is no going back. Now I hope you remember that algorithm examples where we just saw how after second or third step, again if the condition is false or true, again there is a word which we have given as jump to the step 2 option. So we are going back to the step 2 again and we are following. So here in sequential workflow we cannot go back, we'll be continuing in forward position motion. We are not going to move back, we'll be moving forward, we will not go back. So this here we have taken an example of multiplying two numbers, values of n1 and n2. Processing is multiplying those two numbers and then result of multiplication. So here as the diagram, as the flowchart represents, start, input, again we are using parallelogram, read two values n1 and n2, that is we are getting the input from the user, and then we are multiplying. So it is a process, so we are representing it in rectangle format, and then again output, print the multiplication, and then finally we stop it. So both the input output is represented using a parallelogram shape, process is always represented using a rectangle shape, and both start and stop is using an oval shape. Next topic is selective workflow. Many days in our day-to-day problems we need to select one option from various options. In many situations we need to take decisions based on available options. Like if it is raining, we will stay at home, otherwise we will go outside. So let's just take an example of ordering pizza and garlic bread from Domino's. I've just taken an example. You can take up any dish examples, any other dishes, and then you can try out this and draw a flowchart and practice also. While ordering pizza and garlic bread, we have an option to buy cheese dip. So we have an additional option of buying, either you want cheese dip or not. If you want, you order it, or else you need not order it. Here we need to take a decision if we want Chinese dip or not. So this can be depicted in the flowchart using decision making box. I hope you remember the decision making box is that diamond shaped box. So if we want cheese dip, we can order it too along with the rest of the order. Then we can proceed to pay cash. If we do not want cheese dip, then we will simply proceed to pay cash without ordering. So this is the procedure, this is the step which we are going to follow to draw the flowchart. So let's just continue with the flowchart. So as usual, you will start it with the oval shape, and the next flow is that input which we are going to. The input is here is nothing. We are not going to actually. This is not like that preparing mango shake where you have proper items and all. But here we are just ordering it through phone call or something. So we are just, the input here is just ordering pizza and garlic bread. So that is why we have used that parallelogram shape over here. And then the next is, they have an additional option of cheese dip. If you want cheese dip, you can order it, otherwise no need. So you want cheese dip, that will be represented in that we represent in this decision shape. So Every decision box has yes and no answer. So if you want cheese dip, if it is yes, then you order cheese dip. If it is no, then directly you pay cash. If you're ordering cheese dip, again the flow is shown here. Again you come back down here to pay the cash. Even if you order cheese dip also, you have to pay cash. Even if you don't order cheese dip, again without that cheese dip items amount, that will be deducted, and that won't be added, and then you can pay cash. So I hope you are able to understand the flow, how it comes. If you want the cheese dip, yes, order cheese dip. Again it comes down here, and then again the normal process continues. If it is not yes, if you don't want, directly you will pay the cash, and then you get the ordered item, and then finally your process stops. I hope this flowchart is clear. Let's just take another example to explain the selective workflow using a mathematical problem. Now here in this example, we are going to find out the grade of a student using their percentage. That is, if the percentage is greater than 80, the grade is going to be grade A, and if it is greater than 60, it is going to be grade B, and if it is greater than 50, it is going to be grade C, and otherwise if it is less than 50, it is going to be grade D. If it doesn't come under these three categories, definitely it is going to be grade D. So let's just draw the flow chart for this. So again, you started with an oval shape, then you are read percentage of the student, that is, you're getting the percentage from the user, from the student, and then if it is greater than 80, so as I said earlier, decision box always has yes and no answer. If it is greater than 80, if it is yes, you're going to display grade A. Otherwise it is no. If it is yes, grade A, then directly it is going to come down here. I have used a connector here. Two connectors are used, A and B. So with this connector here, it is connected. So it will come directly and it will print the grade A over here, and then it will stop if it is greater than 80. And if it is not greater than 80, again it will come to the next condition, that is, if it is, it will check whether if it is greater than 60 or not. If it is yes, then again it will come here and grade B will be printed and then stop. If it is no, again if it is not greater than 60, and if it will check for the next condition, that is, if percentage is greater than 50 or not. If it is greater than 50, yes, again it will come and print the result. If it is again no, I have used a connector as I am not having space over here, it is connected here then. So last condition, that is, if it is not greater than 50, then definitely it is going to be less than 50. So the grade is going to be grade D. And once you have displayed this, again, you have got the grade, then you have to display the grade. So just print grade, and then you will stop it. So this is how the whole decision making format is displayed using a flow chart. Looping or iterative workflow. In programming, sometimes we need to repeat a set of instructions until a particular condition is met. So that is, the same thing will continue until, say if it is for 5 times or 10 times, it will continue. The loop will continuously print or work until that condition is satisfied. So suppose you want to print IT book 5 times in a program. So in such program, so say something which has to be repeatedly done, repeatedly in a loop, in a continuous way, it has to be done, means we'll use the looping or iterative flow. So looping is used here. Looping will be used if you want to display IT book 5 times. So then again this is called as looping. So every time it comes, it will display IT book. Again second time it comes, it will display IT book. Third time, fourth time, fifth time. When it comes to the sixth time, automatically it will stop, because 5 times only the condition. So for 5 times it has displayed the IT book word, a sentence, and then it has to stop. So we can depict this repeated workflow in the flow chart. So for example, now here we will take up KB school 4 times. So KB school, if you want to display the word KB school 4 times, so this is how you draw the flow chart. So you start again as usual with the oval shape. Then here we are just giving count equal to 1. Say for count is a variable or a text, say assume count is a variable here, and we are assigning a value 1. And then next flow is to print KB school. So for the first time it will print KB school over here. Then again it comes the count value, initially which we gave it as 1, we are increasing the count value to make this loop continuously continue till 4 times, till it reaches the 4th loop. So for the first time we have displayed the KB school word. Again when it comes, we are increasing the count value. So now the count value got increased to 2. Now again it is coming for the decision making. If count value is less than or equal to 4. So now the count value is 2. What happens again? Count value 2, is it less than or equal to 4? Yes, it is less than or equal, it is less than 4. So when it is yes, again it will go up here and again it will print KV school. Again the count value will be increased at this place. Again count value which was 2 earlier, now it will become what? 3. Again it will come to the decision box. Is 3 less than 4? Yes. Again it will go up and again it will print school. So third time also it has printed. Now again the 3 value is incremented to 4 and then again it comes to the conditioning set. Again it will check, is 4 less than or equal to 4? Yes, it is equal to 4. So if it is yes, again it will print, and then now what happens? Again the count value which was 4 will get incremented to 5. Now when it comes to the decision making, is 5 less than or equal to 4? No. The condition is not satisfied over here. So automatically it will come to stop. I hope you all are clear with both the algorithm and flowchart concepts. If you have any queries, post it in the blog or else in the YouTube channel. I'll get back to you soon. Thank you.